Hello, welcome to my presentation. My name is Gustavo Chacón, and before I start, I would like to thank the organization of the RUC-APS project for inviting me to share our team experience with our project. It has to do with plant diseases and pests that affect fresh vegetables. Our case study included the identification and registration of phytosanitary problems in tomatoes, onions, and lettuce produced in the Santiago metropolitan region of Chile. Before I start, I would like to share with you a short introduction about Chile and the Santiago metropolitan area. Next, I will talk about plant health knowledge management system that we named Mateo, the problem we addressed, the solution description, our experience and main results, and finally our future steps or actions that we would like to take, hopefully with the help of some of or many of you who are watching this online conference today. Okay, Chile and the Santiago metropolitan region. First of all, this is a beautiful country which is located in South America. We have all kinds of climate here. For example, in the north, there's mountains. There is agriculture. There's production in the valleys. There's also meat production with camelids. We have a long Andes mountain range all along of our country. We also have wineries at the Central Valley, meat and milk production in the south. And in the very south of Patagonia, there is sheep production and also beautiful places like the San Rafael Glacier. The Santiago metropolitan region includes the city of Santiago, the capital of Chile, yes, along with areas of the Andes and the coastal mountain range. Santiago is located in the Central Valley, is known for its neoclassical architecture. On the outskirts of the city, you can find vineyards with some wine from the Maipo Valley, ski centers, and it is about 1.5 hours from the coast. Now, about my work at INEA. First of all, INEA is the Instituto de Investigaciones Agropecuarias, was founded in 1964, linked to the Chilean Ministry of Agriculture. It is financed mainly through public funds, in addition to competitive research, technology transfer, and extension projects, both public and private, as well as agreements and sales of technological products. Currently, it has around 900 specialized workers, composed of 33 managers, 253 researchers, 298 support professionals and technicians, all of which perform administrative, field, and laboratory tasks for the development of research, technology transfer, and extension to provide services to the agri-food sector in Chile. About my work at INEA, well, I have a bachelor's degree in computer science and engineering from the University of Texas in Arlington, and I have been working at INEA Chile since 1994. For 13 years, I was in charge of the IT department, where I participated in multiple IT implementations for the company, such as the installation of the first internet connection and intranet web applications. I started working as a support professional for the agricultural research area, which is the core of our company. My experience is in applying ICT solutions in rural areas, automatic weather stations network, web application development, closely working with agricultural scientists. Well, these are a few pictures of my work in the field. This is a picture from the north, from the Chungaral Lake, where we have a weather station. That location is about 4,500 meters high over sea level. This is another picture of another weather station in the near San Pedro de Atacama in the Antofagasta region up in the north. And this is a picture of another weather station in the Santiago metropolitan region. We have a web page which is on the screen where people can freely download all the information that we gather automatically every 15 minutes. In the software development area, I work as a hub. I am a hub between users who are usually farmers, IT specialists, agricultural scientists, as well as the policymakers and funding sources. I try to make them all interoperate, so we can meet the goals that we set. Avispate is an example of a web application that is an implementation of a research project. In this project, we combined information from the weather stations and from the biology of the yellow jacket wasp to send alerts to user. When is the best time of the year to control them? The Mateo system, it's an example of a knowledge dissemination application where we develop a database of pictures and symptoms of the different pests and diseases that affect fresh vegetables. In this video, these are an example of a pest that affects onions. It is called thrips. As you can see, these are very high quality and good quality videos and pictures that help users identify very well what the problem is so that they can take the best solutions available. So let's go into directly the plant health knowledge management system. Well, this is a project that was funded by the regional government, the Foundation for Agrarian Innovation, FIA, and the help of the Metropolitan Region of Rural Municipalities Association. Using information technologists, we packed the knowledge of entomologists, phytopathologists, and technical advisors in a systematic way that can help us set up a national plant health management system. We tackled the very first steps of the agri-food value chain, which is the primary production of products of farmers. In this sense, we worked with the small farmers, with technical advisors from a government institution called INDAP, researchers from INEA, and also database of chemical control regulators that are called also pesticides that are allowed to be used in Chile. The wholesale markets of Santiago collects most of the agricultural production in the central zone of the country, and from there the products are distributed in a wide territory. As a result of the large number of supplying agents that converge to the wholesale markets, the observed price levels are quite competitive, so that economic margin of the producers is determined primarily by the cost of production, a variable which is not known to the vast majority of producers in the metropolitan region. One of the production costs are those related to losses produced by pests and diseases. Many small farmers do not have the updated knowledge to handle efficiently these plant health issues, taking into consideration environmental factors and innocuousness. This system has been tailored to meet the needs of stakeholders from the fresh vegetable supply chain to help secure plant health and safety in Chile. In its first version, the project offered the technical advisor of small farmers support in the registration, diagnosis, and control of the three most prevalent diseases and pests that affect onions, tomatoes, and lettuce produced in the Santiago metropolitan region of Chile. We developed a repository of very valuable plant health information that will help us identify and keep track of pest and disease outbreaks in a territory at a farm level. This is the Mateo model. Starting with farmers, technical advisors, solution providers, agricultural researchers, and policymakers, Mateo serves as a knowledge repository of valuable plant health information. Mateo holds a multimedia database of phytosanitary problems such as plant diseases and pests, high-quality pictures and videos of symptoms of the main problems that affect lettuce, onion, and tomato, as well as fact sheets of plant phytosanitary problems, help technical advisors identify and keep track of the pest and disease outbreaks in a territory at farm level. To better understand how Mateo helps farmers, I will compare both the human health system with the plant health system. The plant health system is similar to a human health system in the sense that there are plant doctors, phytopathologists, entomologists, virologists, nematologists, medicines and treatments or control mechanisms. The difference is that we have different plant species or crops which have different phytosanitary problems. We developed this prototype in a 36-month project executed between 2016 and 2018. Doctors were actually agronomists from the Agricultural Development Institute, INDA, who were trained by specialists from INEA. Both institutions are part of the Chile Ministry of Agriculture. We worked with 35 extensionists and 53 farmers who were trained in different field activities. We also developed 18 fact sheets, 18 videos, 18 picture galleries, and 18 posters, one system user manual, one pocket-sized field book, which it was, by the way, the most downloaded publication of the INEA library in 2019. Some of the system features are we're working with 3 pests and 3 diseases, 18 fact sheets with integrated control options of not just pesticides, a database of registered chemical products, farms and farmers database, technical advisors database, printed or email recommendations, public access to a geographically referenced database of reported cases. This is a map of the region, and you can see the different spots that represent the cases. So a user can click on an area, select one of the reports that were entered by the technical advisors, and he has the rights or access rights. He can browse the specific report where the user entered the pictures of the symptoms and described the recommendations that were sent to the farmer. What we would like to plan and to do in the future. First, Given the small number of plant health specialists in a large agricultural areas of the country, Mateo can help make up for this deficit by providing the necessary support. We would like to expand coverage of area and knowledge database with new species, pests, and management options such as biological solutions. Train more technical advisors. Develop a new mobile version with special features. Include weather information. Run epidemiological studies to develop early warning system. These systems should send alerts to users on their mobile phones. And finally, very important is to collaborate with other plant health knowledge banks, such as PlantWise from CABI. This is our web page. Here it is available. All the information that I mentioned, pictures, videos, and news and testimonials, and of course contact with the team that worked in this project. If you have any questions, you can contact me in my email, which is in this slide. And this ends my presentation. Thank you very much for your attention and for inviting me to be part of the RUC-APS project. Goodbye.